I'm Jimmy with PJG's Jewelry, and today I'm going to show you how to set up 3 different types of torches for soldering your jewelry. The first type of torch I want to show you today is just an air butane type torch, and you can buy these online for $40, $50, $60, maybe even $100. They're all pretty much the same. They have some type of reservoir for liquid butane that you can refill from the bottom side, and some type of valve that allows more or less of the fuel gas to come in and be burned, and then typically some type of piezoelectric igniter. In order to turn this on, I'd simply open the valve probably 1/8 to 1/4 of a turn, and you can actually hear the sound of that fuel gas coming out. And if you keep it open long enough without burning it, you'll smell it. Before I do this though, let me go ahead and put my safety glasses on. And again, I'll crack this 1/8 to 1/4 of a turn, and I will press the piezoelectric igniter, and now we have flame. We're getting hot. If you look closely on this, you're going to notice that there are 2 different colored flame envelopes. One that extends out from the tip approximately 1 inch, and it's a really pretty blue. Once you get out further than 1 inch, you get almost an ultraviolet colored blue flame envelope. The first one that I mentioned, actually, technically at its tip, has the highest flame temperature, I don't know, 43, 4400 degrees Fahrenheit. And further out, it's approximately the same, but there are lots and lots of BTUs, lots of heat energy out here beyond that primary flame envelope. And you can see very quickly when I hold this piece of silver solder in the flame envelope that it's going to start getting red fairly quickly. Enough of that. I'll go ahead and turn this off, and we're going to try and get just a little bit hotter. The second type of torch apparatus I want to explain to you today is air acetylene torch. And you notice the red tank here. Red is the most common color for an acetylene tank. Sometimes though you'll see them painted black, and on occasion even gray, indicating that it's a fuel gas, a highly combustible fuel gas. This particular tank has an on-off valve on it with a typical round knob. Some will have a little square-shaped valve that requires a special wrench to turn on and off. But in order to turn this on, remember, lefty-loosey, righty-tighty. So if I were to turn this on about 1/4 of a turn, just for safety, because if anything bad goes wrong, you get a crack in your line, for example, you want to be able to turn this off immediately so the fuel gas does not fill your room space and blow you up. Well, it's turned on about 1/4 of a turn, and you notice that the gauge closest to the tank or valve is showing 4550 PSIG, pounds per square inch. There's another gauge over here, and this is actually showing line pressure. And if I were to crack this right now, it's going to go down to 0. In order for me to get line pressure up, and the necessary pressure is typically about 5 or 6 psi. So I'll turn this T-handle clockwise with the valve cracked open, of course, until we have a working gauge pressure of about 5 PSIG. You'll notice when I turn the valve off, that gauge is going to creep up 1 or 2 PSI. And that's perfectly normal. If I were to open the valve again, it goes back down to approximately 5. Well, the advantage of acetylene burning in air is that though it has approximately the same burning temperature as the butane, the acetylene burning in air actually has more BTUs. And to give you an idea, the flame coming out of here is going to look very similar to what we had with the smaller air butane torch. But there's a lot more heat energy and a lot more variability because I can change the tips. instead of having one simple fixed orifice size with a butane air torch, I can replace the tips with a smaller or a larger or really very large tip to get more heat energy coming out from all the burning fuel gas. As I crack this valve open, I'll just use a spark igniter. I'm going to open the valve 1/8, maybe a 1/4 of a turn, and pointing this away from me or up. Never at your friend. They will not like it. We have fire. And I'm going to turn this down so you can hear me. But again, you'll notice two distinct flame envelopes. One at the very tip that's a very, very bright blue, and one that's almost ultraviolet in color flowing out from that. The greatest heat energy is within about a 1/2 inch off that bright blue primary flame envelope. Again, this temperature is 4,500 degrees Fahrenheit, but there's a lot of BTU or heat energy in this secondary flame envelope. And a lot of silversmiths love using air acetylene. We only have to deal with one fuel gas, acetylene, that you can commonly get from welding stores. And we're going to use Mother Nature's supplied oxygen in order to combust this fuel gas. So again, we're dealing with more heat energy because we're using acetylene burning in air this time. But this is not the only way to get hot. We're going to step up one more level. So let me carefully and slowly just turn this down. We got a little pop there. Listen, I want to get you a little bit hotter. And the way we're going to do that is stepping up to perhaps the most frequently used torch system in silver soldering if you're trying to have the greatest amount of fine control and the greatest amount of BTUs in one space. And that's going to be with an oxyacetylene torch system. And you notice this time with an oxyacetylene torch I have two hoses instead of one. On your left you'll see the one that has red markings on it indicating that's the fuel gas. That's where the acetylene will be coming through to the torch handle. And on the right we have green markings, or sometimes a green hose, and that's where oxygen will be coming through. Well, if you follow these hoses back to the torch system itself, you notice that I have two tanks. We have a gray tank for acetylene and a dark green, sometimes blue tank for oxygen. Just as before with the acetylene air system, I'm going to turn the acetylene tank on first, about a 1/4 of a turn, and you may not be able to see it, but I have approximately 180, maybe 200 psi pressure in the acetylene tank. Whichever gauge, again, is closest to the tank valve is the tank pressure, and whichever gauge is closest to the output hose is the line pressure for the torch. Right now I have a 0 psi, or pounds per square inch of pressure, on the acetylene line, so I'll turn the T-handle in until I get 4 or 5 psi-G. When I turn this little valve off, just as before, that pressure value is going to rise. And we'll do the same thing with the oxygen as I crack this valve open. Well, it would help if I turned the tank on, wouldn't it? And we've got approximately 2,000 pounds of pressure on that. So as I crack my oxygen valve and turn this in, I'll go 5, maybe 10 psi. And as I turn this off, you'll notice this line gauge is going to bump up some, a couple pounds. So both my valves are off. In order to light an oxyacetylene torch system, you have to have fuel gas. Oxygen alone will not burn. If I turn on just the acetylene valve and light this, I'm probably going to have a lot of sooty carbon floating up to a white ceiling in your shop. In order to prevent that, if you simply crack the oxygen valve open just a bit, you'll have 3 flame envelopes coming out from this and not as much soot. So let's see if we can do this. I've cracked that about 1/8 of a turn, 1/8 of a turn, and I'll use my spark igniter to ignite this. You'll notice how the flame is trying to jump off from the tip. I have a little bit too much gas coming out. So I'll throttle this down, but now you notice some soot is rising. In order to get rid of that soot, we'll crack the oxygen valve open. And now all the soot stops, and I can see 3 flame envelopes. One coming out from the tip is the primary flame envelope, and that's the one that burns, that typically is burning at the highest temperature, but it doesn't have as many BTUs. Secondary to that is this multicolored flame envelope, and finally we have this lighter ultraviolet colored flame envelope. Out here is where the greatest amount of heat energy is. But if we had to characterize this entire flame, we'd call it what's called a carburizing or reducing type flame. And the problem with that is that anytime we have a carburizing flame, it can introduce contaminants onto some of the joints. So we're going to reduce this down, and as I continue opening that oxygen valve, you notice that the secondary flame envelope has all of a sudden disappeared. Believe it or not, the temperature at the very tip of that primary flame envelope is about 5,300 degrees Fahrenheit. Out here, 5,500 degrees with a lot of BTUs. This is what we call a neutral flame. It doesn't try and introduce too much oxygen or too much carbon to wherever we're directing the heat. But now I'm really going to get you hot, because I'm going to turn the oxygen up a little bit more. You're going to notice that the primary flame envelope starts to get real thin and a little bit longer, and it starts to hiss. And at the very tip of that primary flame envelope, it's about 6,100 degrees Fahrenheit. But again, the greatest amount of heat energy, or BTUs, are out here. So if you're trying to silver solder, you typically want to be in that secondary flame envelope, but you don't want to have an oxidizing flame like you see here. No, we want to have a neutral flame. So I'll turn the oxygen down until I just start to see that secondary flame envelope appear. This is a lot quieter flame. Right here, at this moment, it's about 5,700 degrees Fahrenheit, with lots of heat energy, 1 to 2 inches from that primary flame envelope. So I hope this has been helpful for you in distinguishing among the different types of torches that we use in silver soldering. But what I really want is for you to keep it hot, because you deserve it.